Hey everyone, welcome to the second video of section 3.5 in the textbook. So for this video, we're going to start talking about the method of undetermined coefficients, which is the first method we're going to look at for how to solve non-homogeneous equations. It basically involves taking a guess at the solution based on what it looks like. It works in a lot of cases, obviously not all of them because you have to guess at things, but we'll see what it looks like and it'll sort of make sense once we get into it. So let's go ahead and start writing things down about it. Okay, so the first method we're looking at for solving non-homogeneous problems is the method of undetermined coefficients. So as we discussed in the last video, we just need to find any solution to the non-homogeneous problem, and that'll give us enough to generate every solution we want because of the form of them that we talked about in the last video. So we need to find something that solves our non-homogeneous problem. So to make things a little easier, we're going to go back and look at just constant coefficient equations again. So back to constant coefficient. That is, we have a y double prime plus by prime plus cy equals some function g of t. And the method involves guessing a solution y with coefficients we don't know with undetermined coefficients based on the form of g. So the method is guess a form for y of t based on g of t. And yes, it is a guess, but in most cases you can make an educated guess at it so you can give yourself closer to the right answer. So for example, just as an example of something that might do this, say g of t was e to the 2t. Well, what does it make sense to guess? Then we should guess y of t is some constant a times e to the 2t. Why does that make sense? Well, it makes sense because if I take derivatives of y, I still just get e to the 2t. I get different constants. I get 2's each front of each term depending on how many derivatives I take, but I still have an e to the 2t. So when I'm done plugging in that y, I'll end up with some function in terms of capital A equals e to the 2t, and I can set that thing to be 1 to get my answer. So this makes sense because derivatives of this y still have e to the 2t in them. So the hope is we can pick a to make it come out to be equal when we're done with it. Now, there might be times where this fails, namely if e to the 2t solves the homogeneous equation, this will fail, but we'll talk more about that in the next video for this section. So second example, say g of t is instead cosine of 2t. Then what should we guess? Well, then we guess y of t is a cosine of 2t plus b sine of 2t. Now your first thought would be, let's just guess a cosine of 2t. But the issue there is when you take a derivative, then you land on a sine. And if there isn't a sine on the right-hand side, that sine's never going to go away. So you need to also put the sine term in there to give you the ability to cancel out the other sine terms, sort of is the motivation there. So why do we do this? Derivatives of y contain sine and cosine terms. So we should be able to make the constants work. And as a final example, say g of t is a polynomial. a(n) t to the n plus a1t plus a0. Then what am I going to guess? I'm going to guess another polynomial. Why? Derivatives of polynomials are still polynomials, so I can hopefully, again, in that case, also make the constants work out. And again, you always want to propagate these things all the way down to the last thing because you're going to be taking derivatives and you want to make sure that you don't take derivatives and leave yourself with not enough constants. So you always want to have constants as far down as the line as you can with taking more derivatives, right? Because the issue is that if I just had t to the n, I don't want just t to the n because if I take a derivative, then I get a t to the n minus 1 and I have to account for that. So I should put tn and tn minus 1 in my equations. But then the tn minus 1 becomes a tn minus 2, and so on all the way down to a0. So I need all of these constants here to make sure that I can cancel everything out but the ones that I want when I get to my answer. This is sort of the same way we have with the sine and cosine term, right? Because I need to have all the terms that show up as derivatives of these things in order to make sure that I can cancel everything out but the ones that I want at the time that when I get done with all these equations. So these are the three main examples, and these are ones you'll sort of see a lot in terms of these types of problems. You can also do products of them. And you get sort of the things you expect. You take the products of the different versions to get the answers that you want. So I'll write those down here as 2 notes. You can look in the book for the actual formulas and how they actually write it all out. But the thought is this: for products of these, guess products of the solution guesses. By that I mean if you have a polynomial times e to the 2t, you're going to guess an arbitrary polynomial times e to the 2t as your solution. And then for sums, guess the sum. So if my g of t was e to the 2t plus sine of 4t, my guess is going to be y of t equals a e to the 2t coming from the e to the 2t term plus a b sine of 4t plus a c cosine of 4t coming from the sine term. So I just kind of add them together and get a more generalized solution that I can then throw in, try to solve the problem, and see what I get out of that. All right. So, and then, I mean, the idea from there is then you just plug these into your equation. You take all the derivatives, you plug them all in, and you try to make the constants work out. So in the next video, we'll see some examples of actually doing this, but I'm going to give you guys a problem to work on now, which is just what solution would you guess for these to do the method of undetermined coefficients. So I'll write that up for you right now. All right, so there's 2 for you to look at. All I want you to do is write the y of t you would guess in order to solve these 2 problems. So take a look in the book if you need. Look at the stuff I did before to sort of piece together what you're going to guess. And the next video, I'll show you some examples for how you then end up finding your actual solution from these guesses. All right, that's it for this video. Thanks a lot for watching, and I'll see you in the next one.